Hello everybody, happy Easter weekend. Seeing as it's a long weekend, I thought I might have a play with some tech, and I was wondering what I might do, and it sort of came to me that I'm quite interested in looking at Raspberry Pis and sensors and environmental sensing and all that type of thing. So I thought we could have a look at that. Now, you may know that for about 6 months or so, we've been working up here in Liverpool, out of DES Liverpool, with Bee for Biodiversity, doing some project work on monitoring bees, which is all rather fantastic. And you can see the My Bees website there. A couple of different things we've been doing. I mean, one is that we've got some live video in there, and you should be able to see now the bees. That's the bees right now on Sunday, 12:30-ish. Doing their thing up on the hive on top of DES Liverpool, central Liverpool. And as well as that, the other thing that we've been looking at here is, if I go back, we've been looking at doing sensing. So, you know, it's quite gratifying that I keep coming back to this, and it's still working, which is, you know, if you're in IoT like me, you know that's quite a big thing. So yeah, so we've got all sorts of things going on here. We've got some gas sensing, light levels, which as you'd expect is down at 0, it's inside the hive. It's some temperature variation, pressure, humidity, and we've got a particulate sensor in there as well for different sizes of particulates, which is something we want to use to kind of look at environmental monitoring, because particulates are a bit, you know, basically can be related to the pollution in the environment, the emissions in the environment, all that kind of thing. So we're monitoring all of this stuff. We're very interested to kind of get into analysis of that, what all that means. Anyway, so this system is running on a couple of Raspberry Pis in the hive, and that's connected over a wired Ethernet cable, which is powered over that cable. It's power over Ethernet, and that goes through DES Liverpool, and all the communications has sort of kindly been lent to us to go through their bandwidth onto the interwebs, and this is how that you can see all this stuff. Thing is, though, that what we want to do next is we want to look at putting some of this kind of technology into hives and places that are more remote. Andrea's got about 35 hives in the northwest of the UK, so not all of these are anywhere near power. We think that we can get radio coverage to get information in and out, but we need to power these things somehow. So it's going to be some combination of solar power and battery power and that type of thing. We want to run some testing over, you know, initially say like 3 months, and then going on to ideally sort of permanent installations. So we can't have systems that are taking too much power. Now, you know, again, if you kind of, you know, if you work with embedded systems and the Internet of Things, you know that there are sort of lower power devices you can use. I mean, people typically might go to like a microcontroller or an Arduino. And then there are more power-hungry devices that you can use, which are often a bit more capable, a bit more powerful. You know, Raspberry Pi is a good example of that, and sort of onwards and upwards. So yeah, I mean, I could take a microcontroller and I could connect some sensors to it, and I could try and run that off a battery, and that would be a pretty standard way of doing things. But, you know, just because I like to play around, why not do things a little bit differently? Well, you know, what we've been doing, if I can sort of show you this here, what we've been doing to date with our bee sensing is we've had a few different iterations. But this guy here is a Pi and Pimoroni Enviro Plus shield, which is a Raspberry Pi 0 shield. You see the back end of the Raspberry Pi there. And it's really nice. I mean, it's really simple to connect the thing up. It sort of goes onto the GPIO connector there. Nice little mechanical design. I can put enclosures for that together pretty easily. Pretty cool. You know, if you go to, let's try just moving the browser across here a little bit. If you go to the Pimoroni page, you can see these guys. You know, they've got all the detail of what is on this thing. And it does all sorts, you know. So again, gas, the kind of stuff that you just saw, the gas sensing. There's a breakout for a particulates unit. It's got a nice little OLED display on there if you want to sort of debug and see things going on. Does audio input, light levels, probably everything I can think of. And you can break it out as well and add more sensors. So really neat little bit of kit, nicely put together. Problem is that the Raspberry Pi, you know, is great at what it does. It's great for prototyping, but it wasn't designed for low power operation. It doesn't have kind of low power modes that some of these other microcontroller chips have. So when you have this thing on, you're kind of eating your current, your battery power if you're running off batteries. So that's a problem for us. Now again, we don't have to do it this way. We could go and use a low power chip, but I'm kind of interested in being able to reuse what we've done in the Hives to date and do that in a different way. So what we currently have on our Raspberry Pi here is we're running an embedded Linux, and we're running something from some lovely people called Balena, BALENA.io, and they provide a kind of a managed framework for Linux, which allows you to remote into systems, and they've got a workflow for kind of, you know, updating containers of software onto systems in a really easy way. You know, for me, it's the future of how we're going to do this stuff for edge devices for embedded Linux, but that's a slightly different story. What I want to do is to try to use this, but in more of a low power scenario. So the key problem is it takes quite a while to boot up. I mean, these things are all relative, but you know yourself, I mean, you think of a Raspberry Pi and then you think of Raspbian or some other kind of flavor of Linux, and it takes almost minutes to boot this thing up, you know. So that's quite a lot of time, and it's quite a lot of power, relatively speaking. Now, you know, I know there are some really clever people out there who have done amazing stuff in terms of how fast you can boot Linux up. I mean, you can find stuff out there where people are turning on a device and they're booting to an application in like 2 seconds or something, which is, you know, is not to be sniffed at. But that isn't something that is, as far as I'm aware, standard today. And you kind of get into a lot of jiggery-pokery trying to optimize that boot process for specific hardware, specific use cases, and so on and so forth. Now, we could do that here. That's an option. But again, you know, it's a long weekend, and I want to have a play with some tech. So, one other alternative is that if you're, you know, kind of old school, you know that this Raspberry Pi is basically just a little computer that adds things up. It's a system on a chip that's got an ARM core or a variant of an ARM core, and there's no reason that you have to run embedded Linux on it. You could run other numbers on it to make it do other things. So I had to think to myself, and I thought, you know, well, there's so many clever people out there nowadays. There must be some people who are doing this, who are doing sort of fast boot on what I would call bare metal on the Raspberry Pi, and by that I mean you haven't got all of the, you know, full fat operating system and a nice desktop and all that kind of thing. You haven't even got a kind of a basic operating system or a real-time operating system, as we would call it. You're just talking to the hardware, to the registers, and it's all very, very low level. It's kind of a scary place to be, but it's also quite a fun place to be as well, and you can really do a lot of optimization, get sizes of things down, get speeds of things up, and, you know, if that is your want, you can play with that. So I did a shout out on Twitter, and people very kindly pointed me in the right direction, and particularly a shout out to UK Scone there, who put me onto this project, which is over on GitHub. It's Circle, seems to be called. Reset A2. Is that a reference to an x86 addressing line or something? I don't know. Maybe I'm overthinking this. But so if you look at this is a sort of typical, lovely, nice, mature, well-documented open source project. And this is why I love open source, because there's all these super clever people out there, and they've done all this amazing work. And all you've really got to do is think of something that you want to do, and you can build, you know, really build on the shoulders of giants, of clever people. So they've done all sorts of interesting stuff with this project. It's got a bunch of system support for all sorts of different components on the different kinds of Raspberry Pis available, ranging from, you know, we've got here all the sort of basic stuff. We've got GPIOs and displays, UARTs, I2C, even Ethernet and wireless LAN, you know. So this is pretty comprehensive. Now, you know, I've only just found out about this, so I'm guessing a lot of things, and I could well be wrong. So don't believe a word I say. Go and have a look at this and talk to them. But basically, what we're going to do is we're going to be able to build up a little bit of code in a kind of a bare metal on the hardware kind of way, and then we're going to put that onto an SD card that we're going to boot from, same way you would boot Raspbian or something. And if we get this right, we should be able to boot really quickly and do some stuff and do some sensing, do some sensor stuff. Now, why bother? What's the point of this? Well, as I said before, if I can make this work, then what I can do is I can have a kind of a small communications chip, and you can get these, they're out there, and that's what I need to get information in and out of remote locations. And I can use this little communications chip to turn on the Raspberry Pi, do its stuff, do its sensing, get the outputs, and turn it off again. Now, if I can do that quite fast, then I can do that multiple times a day, and I'm still not going to kill the batteries. I'm still going to have a decent lifetime on the batteries. So if I was to do it like once an hour, 24 hours a day, over 3 months, that would be something I'd be aiming for. With a more deeply embedded device, we're kind of looking at 5 to 10 years of battery lifetimes. So I think a few months should be eminently doable, turning a Raspberry Pi on and off. I might be wrong, of course. So, okay, next steps. What can we do? Well, let's grab the code and let's see if we can build it up and we can get it onto the platform. Now, what I'm going to do is stop recording, and we'll start another session up, and we'll do that in that session. So, thanks for listening.